Yo, what's up everybody? What I have here today is a statistics regents review. So since we finished all the statistics lessons or the chapter, what I like to do is make a regents review based on that. So these are all regents questions and all types of statistics regents questions that have come up over the years that I think will be a great review to learn or to review all the different things we have learned in the previous lessons. And what I have is the calculator buttons for each problem that you're going to need, or if there's no work, I specify that. And then we're just going to go through each one piece by piece as they're all mixed together and see how we do. This is probably going to be a longer lesson. Usually my lessons are about 9 to 11 minutes. This is definitely going to run longer. But it'll be a great review for statistics, and it'll be a great review for your regents if you're taking that at some point. So let's dive right into it and see what we have. When we look at this part 1 regents question right here, it says the scatter plot below shows the relationship between the number of members in a family and the amount of family's weekly grocery bill. Then it says the most appropriate prediction, okay, of a grocery bill for a family that consists of 6 members is. Now this takes no work, and usually a question like this comes up in the beginning of the Regents exam. Now since they're talking about a prediction, guys, what I would like to do here is I would draw a line of best fit. It doesn't have to be perfect, right? But we know it's got to go through the middle of the data. So it'll look something like that, okay? Not a perfect line, but it will give you an idea. So it says family of 6 members. So we go to 6, we go up to our line, boom. And now we go over here. How much money will it cost? Bang, $300, choice 2. Simple. Part 1 statistics on the regents. You get it right and you move on. Let's look at another one. Here is another statistics question, okay, that also requires no work. You just have to read it carefully and think about what you know about correlations, which we have learned. And it says, what type of relationship exists between the number of pages printed on a printer and the amount of ink used by that printer? Well, think about our correlations, guys. We talked about that. We had positive correlations, we had negative correlations, and we had no correlations. Now, remember, think about it. As you print pages, you're going to use ink. So as the X value increases, so does the Y value. Well, what do we say about that? As X increases and Y increases, we know that is a positive correlation. Okay, since we know it's positive because both of these variables are increasing, we know we can get rid of 3 and 4. Now the regent says this, it says, but not causal and causal. Well, if you have to use ink to print your pages, then it is absolutely causal, so your answer here is choice 2. Because guys, without ink, you are not printing any pages, all right? So there's another very simple one that takes no work. You just had to think logically. Okay guys, now notice in number 3, this one will take some work, but here's the good news. It's going to use the calculator, which is awesome. Now we learned this already, we learned the buttons, but I put them here for you just as a review purpose, so if you do need them, here they are. It's exactly what you need for this type of problem. The problem says, Noah conducted a survey on sports participation. He created the following 2 dot plots to represent the number of students participating by age in soccer and basketball. Which statement about the given data sets is correct? Now just remember guys, we talked about dot plots. Remember, you have ages 6 through 12 here for soccer. So this is a 6-year-old. How many 6-year-olds are there? There are 3 because you have 3 dot plots. Each dot plot represents the number of kids you have. That's how you read this. It's very simple. So, which statement about the given data set is correct? Choice 1 says the data for soccer players are skewed right. Well, guys, as you look at the soccer players, that is clearly not the case. They are not skewed right. So, choice 1 is gone. So, you get rid of it. Choice 2 says the data for soccer players have less spread than the data for basketball players. Well, guys, the spread is the same actually in both. So, that is not true. So now we're looking at choice 3, which talks about the median, and choice 4, which talks about the mean. Well, guys, if you need the mean and median, this is where we go to the calculator. So remember, we talked about this. The first step is always to clear your calculator. Second function plus sign 712, and now we hit stat enter. Now we're going to put the soccer players in first. You cannot put both of these in the calculator at the same time. So remember what we said, each dot plot represents the number you have here. So there are 3 dot plots, so that means you put 6 3 times. 7 4 times, they all go in the L1. We're only using L1 for this. 2 8s, 2 9s, 3 10s, 2 11s, and 2 12s. And there you go. Remember, stat right enter and you scroll down. Stat right enter. You have to hit enter about 4 times and you scroll down. The mean, 8.66667. So let's write that out for the soccer players. So we'll do 8.6. And your median. You scroll down for the median, guys. The median is 8.5. All right, now that's for the soccer players. Now we need to put in the basketball players. So you go back to your calculator. Again, I always like to clear it. This way there's no problems, just in case a number gets left in there on accident or anything happens, it'll get messed up. L1, so we have 1 6-year-old, 1 7-year-old, 2 8, 3 9, 3 10, 4 11, and 4 12. Okay, stat, right, and enter. Here we go. The mean is 9.8 and your median is 10. So now this is for the basketball players. Your mean, 9.8, and your median is 10. So now, choice 3 says the data for basketball players have the same median. Well, guys, 8.5 and 10 are not the same, so we get rid of that. So just by elimination, it's choice 4. Now, what does 4 say? The data for basketball players have a greater mean than the data for soccer players. Well, 9.8 is greater than 8.6, so that is correct, and that's why that is your answer. So guys, that's how you solve that question using these buttons in the calculator with your stat enter and your stat right enter. Simple. Let's look at another one. All right, guys, this one also has no work. You just have to read the graph carefully. It says the graph below represents a jogger's speed during her 20-minute jog around the neighborhood. Which statement best describes what the jogger was doing during the 9 to 12 minute interval of her jog? Now, I remember this question, and I remember a lot of students getting this wrong. All right, they looked at 9, they looked at 12, and they saw this flat line here. A lot of students picked choice 1, she was standing still. But guys, you have to look at your graph. The y-axis talks about the speed. That means 2 miles per hour, 4 miles per hour, 6 miles per hour, right? Well, there's no way she could be doing 6 miles per hour and standing still. So choice 1 is definitely not our answer. Choice 2 says she was increasing her speed. Well, from 9 to 12, guys, the speed stays exactly the same. So she wasn't increasing the speed. She wasn't decreasing the speed. She was jogging at, what we're looking at here, a constant rate. Constant rate means the speed does not change. So from 9 to 12, she is going 6 miles an hour the whole time. Choice 4. Guys, no work. You pick that and you move on. Let's look at another one. Okay, now the Regents hit you with this one that will take some work, but again, we learned these buttons, so you know it in your calculator. This will be easy. It says the table below shows 6 students' overall averages and their averages in their math class. If a linear model is applied to these data, which statement best describes the correlation coefficient? Guys, remember, correlation coefficients are always your R equals value. We talked about that. How do you get your R equals? You must put the matrix or your diagnostics on. So you got to hit your matrix button to put on diagnostics. As always, let's clear the calculator. Second plus 7, 1, 2, enter. Whenever you're putting on diagnostics and you're looking for correlation coefficients, you're going to be using both L1 and L2. So you hit stat enter. The top goes in L1, the bottom goes in L2. 92, 98, 84, 80, 75, and 82. Hit the right arrow to get to L2. 91, 95, 85, 85, 75, 78. Now, I didn't put my diagnostics on. Here's what you do. Let's say you forget to do that. You put your data in, no problem. You hit second, 0, matrix. You scroll down to diagnostics on, and you hit enter twice. And there you go. So you could lock in, you can put your diagnostics on at any point throughout this problem. I should have did it first, but I forgot to. So that's okay, it's on. Now you hit stat enter again. Your information is already in. See, all your information is there, so don't panic. Now you hit stat, right, 4, enter. Boom, and there we go. What is our R value? R equals 0.924. So that means R equals 0.92. Well, guys, what do we know about 0.92? That's positive, and it is strong. It's positive and strong because 0.92 is, well, that's close to 1. 0.92 is not close to 0 or 0.5 or negative 1. 0.92, guys, is close to 1. That's why we call it a strong, and this is just for review purposes, strong positive. All right, that's just to review. You didn't need to do all that. You just need to know that 0.92 is close to 1. You pick your answer after using your calculator, guys, and you move on. We're doing well. Okay, let's look at another one that takes absolutely no work. It says the number of hours spent on math homework during 1 week and the math exam grades for 11 students in Miss Smith's algebra class are plotted below. Based on the plotted data, what is the, here's that word again, correlation between the time spent on homework and the exam grade? Guys, you just have to use your eyes here. Basically, you know the scatter plots, they are increasing. What did we say about a positive correlation? As the X value increase, the Y values increase. Well, that's what's happening here. If you draw a trend line, it looks like that. These plots are increasing. Therefore, guys, this is a positive correlation. No work needed to be done. You just had to recognize that they're increasing and that it's positive. Simple. Let's take a look at another one. Another easy one, guys. This takes like very little work here. Most of it's not work, it's just review. It says, based on a box and whisker plot, which statement is false? So choice 1 says the median is 7. Well, real quick, guys, here's what I'm going to do. I'm just going to label this. This is your min for review purposes. This is your Q1. This is your median. This is your Q3. And of course, this is your max. Whenever you have box plots, guys, you always want your 5 statistical data summary. So that's what you have here. So it says the median is 7. Well, that is true. We don't want true. We're looking for false, so get rid of it. Just to cancel these out, the third quartile is 11. Well, here's Q3. Here's your third quartile. That is also true. The first quartile is 4. Here's Q1. That is also true. Process of elimination, our answer is 2. Here's Y. It says the range is 12. But guys, remember, range is always, and this is for review, max minus your min. Well, my max is 12. My min is 2. 12 minus 2, the range is actually 10. And that's why that answer is false, which is what they wanted, which is why that is our answer. All right, so the only work you had to do is subtract. Very, very simple. Don't forget box plots. They are easy. Let's take a look at another one. Okay, guys, on this one, we got to go back to our calculator. It says Jean's scores on 5 mathematics tests were 98, 97, 98, and 96. Her scores on 5 English tests were 78, 84, 95, 72, and 79. Which statement is true about the, and here's what they want, standard deviations for the scores? Guys, standard deviations are very simple to find, again with the calculator, and these are the buttons you're going to use. The only issue is you don't have one set of data here, guys. You have two sets. You have a set for math, then you got to find the standard deviation for the set of English. Clear your calculator. Second, plus 7, 1, 2, enter, stat, enter. Everything goes in the L1, so we're going to do the math test first. So 98, 97, 99, 98, and 96. Okay. Stat, right, enter. Standard deviation, guys, is this symbol right here. It's 1.019, so I'm going to write 1.02. So for math, our standard deviation, sloppily written, I'm sorry, is 1.02 because it rounds. 1.02. Now we need the standard deviation for English. So we're going to go back to our calculator. Clear it out. Second, plus 7, 1, 2, enter, stat, enter. And let's put now the English scores in 78, 84, 95, 72, and 79. Stat, right, 4, enter. Whoa! Oh, what did I do, guys? You know what I did? I hit stat, right, 4, enter because I got crazy. That's insane. We don't want that. Hit stat, enter. If you ever mess something up, I'm glad you saw that. So I messed up and I hit the wrong button. We don't hit 4 for this one. I just got crazy for a second. If it says syntax error, guys, you just hit quit, you go back, hit stat, enter. Your information is still in here. We want to hit stat, right, and then enter. See, I got nuts. Sorry about that, guys. Okay, standard deviation, 7.709, so 7.71 is the standard deviation for English. 7.71, okay? Now, choice 1, the standard deviation for English scores is greater than the standard deviation for math scores. Well, that's true. 7.71 is greater than 1.02, so that, the first one, is your answer. Choice 2 says the standard deviation for math scores is greater. We know that's not true. Standard deviations for both are equal. That's not true. And then it says more information is needed. That's not true. Choice 1 is your answer. So I'm actually glad I made a mistake there because it showed you what happens if the calculator gets jammed up. You just go back to the beginning, you hit stat enter, your information's still there. Let's take a look at another one and hopefully I don't make a mistake on this one. Okay, so guys, this is a good one. No work needs to be done. Again, just reviewing what we know about correlations. It says a student used the equation of the line y equals negative 0.09x plus 9.24 to model the data. What does the rate of change represent in terms of these data? And I forgot to read up here. It says a student plotted the data from sleep study as shown in the graph below. All right, so you have a scatter plot here. That's what it is. Notice they're trending downward. Since they're trending downward, guys, we know it's negative. So anything with increasing or positive cannot be our answer. Also, you have a negative slope or a negative rate of change here. So again, anything that is increasing cannot be your answer. So right away, get rid of choice 1 and you get rid of choice 3. We know it's decreasing because we see them decreasing. We see the negative here. Well, guys, your rate of change is the same exact thing as your slope. Well, guys, this is your slope right here. Boom, 0.09. So there you go, choice 2. The average number of hours of sleep per day decreases 0.09 hour per year of age. Simple, no work needed to be done. You just had to know your rate of change is your slope and what that number was, which is right here. Simple. Let's go on to the next one. Okay, here's a part 2 on a Regents. Notice it's not multiple choice. And it says, Robin collected data on the number of hours she watched television on Sunday through Thursday nights for a period of 3 weeks. The data in the table is shown below. Okay, here it is. Using an appropriate scale on the number line below, construct a box plot for the 15 values. Guys, don't forget how to construct a box plot. They are simple. These are the buttons we need for that. These are the 5 measures of statistical summary data you must write out. I just didn't write it. I wanted it typed so it's nice and neat for you. First step, clear your calculator. Second, plus 7, 1, 2, enter. Stat enter. And whenever you do box plots, guys, all of this whole table is going to go in L1. So 4, enter. 4.5, enter. 4, enter. 3, 5, 3, 3.5, 2.5, and 1, 2, 3, 1.5, 2, 1.5, 2.5. Stat, right, enter. And there you go. We need to scroll down, and there's your 5 measures right here. Min all the way through max. Well, the good news is you get a point just for identifying this. So our min is 1, Q1 is 2, median is 3, Q3 is 4, and your max is 5. Now remember, I get a lot of questions about how to number the number line here. Guys, keep one thing in mind. To make life easy, just start with a number less than the min and end with a number greater than the max. So since the min is 1, well, I'm going to make this easy. Let's start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now remember what I said, when you are actually drawing this, you put dots where these numbers are. So I'm going to put a dot. Remember, it's always above the line, never on the line, always above. 2, 3, 4, and 5. Remember what I also said, draw a vertical line through the second, through the fourth, connect them as best you can, of course, and then draw one through the middle. There's your median, and then make your whiskers. Bam, bam, and you can even do this if you like. And there you go. That's it, guys. That is your box plot for the 15 values. Full 2 points on your Regents, getting full credit. That is simple. If you see that, guys, it comes up every once in a while. Get it right. Let's look at another one. We're almost done. Okay, guys, I have to be honest. This is absolutely, out of all the statistics questions on a Regents exam, this is my favorite. The reason why? Because this is a part 3 worth 4 points, and it's super easy. It says the percentage of students scoring 85 or better on a mathematics final exam and an English final exam during a recent school year for 7 schools is shown in the table below. All right, so now here's what we have. Here are the buttons you need. Why do we need our matrix and diagnostics on? Because it says this, write a linear regression equation. That's easy. And then what do they want? The correlation coefficient. And then they want you to talk about the context of that in these data. Guys, this question is simple. Your first step, get this in the calculator. Here are the buttons before you do anything, clear it. Second, plus 7, 1, 2, enter. Let's put diagnostics on right away. I failed to do that last time. Scroll down. Remember, when you put diagnostics on, guys, you have to hit enter twice to lock it in. Now it's stat enter. L1, L2, 27, 12, 13, 10, 30, 45, and 20. Hit the right arrow to get to L2, 46, 28, 45, 34, 56, 67, and 42. Stat right 4, enter. Stat right 4. And there you go. Remember, for linear regression, guys, you must write the A and B values. You will get a point for that, so let's do that right away and lock that point up. It says to the nearest hundredth. So your A value is 0.957, which is going to round to 0.96. Your B value, 23.948, which is going to be 23.95. Now, in order to get the second point, guys, you need to write out y equals ax plus b, y equals, and now just substitute this information into your function here, a. Instead of a, you have 0.96. So 0.96, x comes down, plus 23.95. And that, guys, is your linear regression equation. Simple. There's 2 points on your regions. Now it says correlation coefficient. Well, this is easy. It's right here for you. R equals 0.92. Says to the nearest hundredth, so that's what that is. R equals 0.92. Simple. There's a third point. Now, how do you get the fourth point? Well, we know. Explain the meaning of this value in the context of these data. Well, this is a strong positive. And I'm sorry about the flashing there with the strong positive correlation, because 0.92 is close to +1. Simple. And that is true, guys. 0.92 is close to 1, and we know that is a strong positive correlation. Simple. 4 points on your regions. That is huge, and it's easy. Just, of course, using your calculator. Last question. Okay, this is going to combine the one we kind of just did, like a regression equation we're going to have to do, but then we're going to have to talk about plotting residuals. Simple. Again, buttons are the same. Now, even though we're not getting our correlation coefficient, just be used to putting the matrix on and getting your diagnostics on. All right, so let's clear this out. Second plus 7, 1, 2, enter. Second 0 matrix, just practice putting that in so you don't forget it. The more times you do it, the easier you'll remember it. You hit enter twice. Stat enter. Now, you have 3 columns here in this table, guys. It says, use the data below to write the regression equation y equals ax plus b for they want the raw test score, which is here, on the hours tutored, which is here. So for your regression equation, we're focusing only on these 2 areas right here, okay? Round all values to the nearest hundredth. So let's put the hours tutored first. 1, 2, 3, 4, 5, 6, and 7. Hit the right arrow. Now we want to put L2, the raw test scores. 30, 37, 35, 47, 56, 67, and 62. Just like the previous problem, stat right 4, enter. Stat right 4, enter. And there's your information. We do not need the correlation coefficient for this one, but we do need our A and B values. Well, to the nearest hundredth, A is 6.32. 6.32. Your B value is 22.428. That's going to be 22.43. And now you put it into the linear function formula, which is right here, y equals ax plus b. So it's going to be y equals 6.32x plus 22.43. I got to squeeze it in there. That's crazy. Okay. There is your regression equation that you needed. There's 2 points right there. Now, let's look at the next part of this. It says, create a residual plot on the axes below using the residual scores in the table above. So you still have to use your hours, guys, because that's your x-axis, but now we're going to plot these residuals, which is going to be the y-axis. So here's what we're going to have here. The first one says 1 and 1.3. So we go over 1, and 1.3 means you go up, and then you go just a little bit above the 1 there. It doesn't have to be exact, guys. Next one is 2 and 1.9. So you go over to 2, 1.9, a little higher, right about there. Doesn't have to be perfect. 3, negative 6.4. Over 3, down 6. And then the 0.4 is going to be right about here. Again, doesn't have to be perfect. 4, negative 0.7. So over 4.7, guys, negative is going to be right about here. 5, 2. So over 5, up 2. 6 and 6.6, which is going to be here. And finally, 7 and negative 4.7, which is going to be here. Okay, so now that you plotted that, that's the third point on the region. So what's the last point say? It says, guys, based on the residual plot, state whether the equation, and we talked about this, a good fit for the data. Remember, there's good fit and there's not a good fit. Okay? Remember, good fit does not form a pattern. Not a good fit does form a pattern. Justify your answer. Well, what do you see here? There is absolutely no pattern here. Since there is no pattern, guys, we say that this equation is a good fit because the residuals do not form a pattern. So guys, that's basically it. There's another very easy 4-point statistic question for you. So this is basically just reviewing statistics regions questions. Okay, comment below on what you liked, what you didn't like, what you want to see. Any questions for me about this or any of my other lessons, please email me at bwritingcihs@yahoo.com. Please like, share, and subscribe if you haven't done so already. And guys, thank you very much for watching. Please stay safe, and I'll see you guys on the next video lesson. I believe the next topic we're going to start is factoring. So if you need help with factoring, come join me for that. Talk to you soon. Stay safe. Peace.